So here we are. This is the last lecture, Chapter 9. People can give presentations if they want to, the ones that didn't do it last time. And then next week we have a guest speaker, and that's the last class. This class I won't be here. I will be on an airplane on the way to China. Or somehow I will be out of action, and the final will be available online.
How many questions?
Well, about 20. I'm not sure exactly how many, but I can get a little closer. Let me look at the scores will tell me. Here we are. By the way, all the green people already have an A. But anyway, the final is 60, so I guess it's only 15 questions. 4 points per question. 15 questions. So like 3 quizzes. So not too hard. You only get one try. You get an hour to do it. So that's there at 60 points. And of course, it's pretty easy to do some extra credit of some sort to make up for that, and a lot of people have. But anyway, the green people have an A, the yellow people already have a B, and the rest of you can check here to see how it's going. And I see that there's 20 points of some kind of extra credit missing from my total there, which means probably there's another column I need to put in for RSA or something. Yeah?
Hey Sam, so I was looking to the extra credit ones. What is I think what is it? The Angstrom? Or what is that?
That was a CTF. Happened about a month ago. So if you didn't do it, it's over.
Okay. Is the Easy CTF still available, or is that something also?
That's also over.
Okay.
But Pico CTF is available.
Okay, cool.
Good.
So if you did that for 140, it doesn't count for
What's that?
If you did those two for 140, does it count here as well? Or?
No, just one or the other.
Okay.
You have the same number of points. You can put it in one class or the other.
Oh, okay, good.
Good. Any other questions? If you have any questions about grading, it's definitely time to address them.
Oh, so I actually had 2 assignments missing. Did I just email my?
Yeah, email them in. Yeah, let's make sure you get your credit for it.
The final exam online?
What's that?
It says final exam.
Yeah, that'll be online
Like
in a couple weeks.
in the campus.
It'll be in campus, just like your quizzes.
Got it.
Except it'll be an hour long, and you only get one chance to do it. Good. All right, so let's talk about software development security, and I should preface this with a caveat that I have no idea what I'm talking about. I've never written software at this level, so all I know is pretty much what it says in the book. If any of you have any actual software development experience, please chime in with more information, because all I know is what books tell me. I've never developed software in this kind of team or anything. I just know the basic ideas. I've written plenty of code, but I was just a single developer in an unorganized place. I've never been this thing where you're a team of 1,000 programmers all working together to make a huge project go at a big corporation like Microsoft, and that's what this is about. So my knowledge of this part, I know. Okay, so basically you got the machine code. This is built into the CPU. This is the binary that actually runs, flipping the bits back and forth. Then you have human readable language. Now, assembly language is the lowest level human readable language. It's higher level than machine code, where instead of just showing bits, ones and zeros, you show instructions like move and such, and jump not equal and that sort of thing. It's not very readable, but it's the attempt to make machine language somewhat readable. And then most programmers program in higher level languages like C or Python or JavaScript. And then your program runs through some kind of compiler. Some languages are interpreted, so the compilation happens just one line at a time, but the processor only speaks machine language. So it has to take whatever you've written and turn it into machine code ultimately. Interpreters do this one line at a time while the program runs. Compilers do it to the whole program before you run it. And then there's this intermediate thing used by Java, where you have a Java virtual machine which runs bytecode, which is a sort of machine language, sort of assembly language. It's independent of the hardware. So you compile your program sort of halfway down to bytecode, and then you run it in the bytecode on Java virtual machine, so you can run it on any operating system. And it therefore is somewhat slower and buggier than native code, but you do not have to rewrite your app to move it to a different platform. So that turns out to save so much money that people are willing to put up with the enormous inconvenience of using Java, which is spectacularly unpleasant to use. But there's #1 programming language. I saw it last month. All of them is Java. Most common one because it saves businesses so much money to just write all your stuff in Java. So procedural languages use subroutines and functions like Fortran and C. This is a really old technique, been around since the 80s. Object-oriented code came up later with another layer of abstraction. You can define these data structures that have attributes and methods. So you'll have something called an employee, and the employee has attributes like a pay scale and a social security number and an address, and the employee has methods like promote or demote or something. So you have active code and static data all attached to an object, and now you can have another object based on the first object that inherits all that. So it's these abstract containers in the object-oriented language contain code that might be written in a procedural language, and that turns out to be the right level of abstraction for modern work, like C++, Ruby, and Python are all object-oriented. So Metasploit is now written in Ruby, and this is what Ruby looks like. You define a class called Metasploit, and you have these double colon things which indicate containers. So there's an MSF object that contains a subobject called exploit, a subobject called remote. You include these other things like libraries, then you define this method called initialize, and on you go. This is common for object-oriented languages. They have a constructor which runs the first time you use an object to create an object, and when you're done with it, it runs a destructor to destroy the object and free up the memory, and then there are other methods depending on the object that run. So it's actually quite readable like English, but it does include some basically set theory. This form of abstraction where you now define an object called a Metasploit 3 object. And that Metasploit 3 object includes many things. All right, so the next generation is coming now where we will have automatic code generation. There's already things that will automatically generate little snippets, fix syntax and things. But what's coming very rapidly is artificial intelligence. So the next version of things like Visual Studio and such will have an AI that will help write common types of code and help you. Just like we now have these self-driving cars that are not really intended to drive 100% independently, they're intended to help you drive.
Are those based on like common design patterns or something? Like you want to do this type of thing, so here's the best way to do that?
Yes, I think the first generation is really just sort of like Clippy. It looks like you're writing a suicide note, why don't I give you a hand?
Yeah.
But I think it's they're getting smarter and smarter. And AI is jumping forward really fast. And one thing that's happening a lot with all the IBM products is they all connect to Watson, which is running in the cloud.
Okay.
So you get Watson's help from this massive cloud machine that you can't afford to help see what you're doing and suggest a better way to do it.
It would be nice to be able to visually do a flow chart and have it generate the code right off of that.
Yes, and there have already been tools for that for a while. There's Android tools that will do that. You drag and drop things like puzzle pieces and it writes the code. And that's where more and more of that is going to get more and more powerful. So, all right, so here's computer-aided software engineering, like I say, to program. There are tools that support one task, there are workbenches, and there are environments, like I think Visual Studio would count here, that just has a whole bunch of things in a big framework that just help you do everything. There's two general ways to go. There's top-down, like management, where you start from the overall management level description of what you're trying to accomplish, and then try to make it go. And then there's bottom-up, where you start with low-level details and try to match it to the task. Closed source is when your company keeps it all as a proprietary secret, and you might even patent it so nobody else can use it. And this is like Microsoft and Apple for that matter. They lock everything up. Nobody gets the source code for Windows. And open source is the alternative, like Linux, where everything is available for anybody to see. It does, and then there's free software, which is the thing that came from Richard Stallman at MIT is the main advocate of this. And what he means is not free in the sense of costing you money, but free in the sense of not locked up. It's free in the sense that anybody can see the source code and modify it. They believe from the very early days of computing, they really liked hackers. They said, you should be allowed to modify anything to make it do your way, and it is morally wrong to lock it up so we can't modify it. That ship has really sailed. These guys are basically just a small cadre of fanatics these days. This is where it's at. The fact is, 99% of your users have no ability to modify the code and no interest in modifying the code, and what they really would like is to be sure that no criminals have been modifying the code, so they would rather have something like an iPad where you can't change anything and it can't get infected. That's what most people want who are non-technical. But anyway, that's the game. There's different monetary licenses, freeware, shareware, and crippleware that give you all or some of the functionality for free. So public domain is stuff that's completely free to use, modify, do anything you want with, although some of them have like the GNU public license where there are some restrictions. You aren't allowed to sell it for money. You aren't allowed to modify it and sell the modified version without adding the source code and things like that. You can sell it for money under certain conditions, but only if you do distribute the source code with it. Then there's proprietary software. There's a user agreement. If you use something like Microsoft Windows, you have only a limited ability to use it. You're allowed to install it and run it. You're not allowed to reverse engineer it and modify it, although a ton of people do that. And they're all technically breaking the law, but usually they don't try to prosecute you unless you actually make a pile of money or something. And then there's the various open source licenses that limit the rights to some extent of what you can do with these things. All right, so the very old-fashioned way to do this was you would have a project and you'd have a lot of steps, and you would just do the steps one after the other. So you define the requirements of the hardware, then the software, then you analyze it, then design the program, code it, test it, and ship it out the door. This is the really old model based on an assembly line where you start with a pile of junk and you build a car and you send the car out and the job is done. And as we all found out the hard way with both cars and computers, this is not true at all. Once you send it out the door, then you take the money, you want to be done, but then the customer comes back next week with complaints and there's product recalls and upgrades, and it turns out that it's a whole lot more complicated than this. So the modified waterfall model is where you detect something wrong here and you send it back for reworking. That's the simplest thing, where you keep on kicking things back because there's a problem. Because one other problem with this model is often the easiest way for this team to solve their problem is to just create a bigger problem for the next team. That's very common. And so then they'd have to kick it back and say, no, you've got to do a better job of your part so it doesn't make my job impossible. And then there's a sashimi where the steps all kind of overlap and blend into each other. And then there's Agile. And here you have the idea that instead of having teams that can succeed better by just dumping their work on somebody else, which is how old-fashioned businesses work, like City College is very, very much this way. You probably noticed. If you have a problem with your registration, you go ask somebody, they'll just tell you, oh, go ask somebody else. And they'll tell you to go ask someone else until you're running around in a circle, because everybody doesn't actually find the best solution is not to do their job. The best solution is to refuse to do their job and make someone else do their job. That's how most government is. And they try to fix this way by having a team that will just stick with it all the way. That's the idea, to be agile. So Scrum is one way where one team has to take the project and the same people have to do all the steps right to the end. So they cannot duck work by dumping work on another team. They have to actually solve every problem. That's one way to go. This thing called extreme programming has pairs of programming. So two people work together all the way, so hopefully they will notice if someone is making a bad assumption or doing something in an inefficient way. That's the idea. Paired programming, work weeks, customer involvement, and test procedures. All these are trying to make software develop more quickly and be more accurate, because it turns out that with these old models you can waste an incredible amount of time doing work over and over and over. Because it's not very efficient at getting the job done and making sure that you're really accomplishing what the customer needs. Then there's Spiral, which is probably much more realistic for what really happens here for something like Windows. In fact, Microsoft has said they're not going to quit having Windows versions. They're just going to have Windows 10 and just keep updating it and updating it and updating it forever. So you make one version, you set your requirements, you make a prototype, you get the concept, make your prototype, and then you come back and do it again, risk analysis, and improve it, and just keep improving it and going around and around forever. That's where Microsoft has finally decided to live, in just an endless loop, because the old days when you put Windows 95 in a box with a floppy disk and sell it and take the money and then you'd write Windows 98, that's not really the way it is anymore. Everybody's constantly putting on patches and updates, and they're really trying to get all their products here like Microsoft Office 365, where you don't buy it at all, you just lease it. You pay a monthly fee for using it. And with things like Amazon, you don't even own the hardware. You just lease the server in the cloud, you lease the ability to use that cloud service, and that's probably much more realistic to the way things are. You subscribe to things rather than really buying something and owning it, and then having to buy another one later. So rapid application development is another one intended to quickly meet your business needs. So prototyping is where you create mock-ups that do some of the function in a very simple way, just so you can quickly show the customer some version of it, so you can get a lot of feedback from a customer, because web designers are the ones I hear complain about this the most. The customer asks for something, you do it, they look at it, say, oh no, I want it all different. So you do that, and then they say, oh no, I want it back the first way, oh no, I want it halfway in between, and they drive you insane by making you do the job over and over. So having frequent feedback steps where the customer sees what you've been doing is the plan here. And this the software development lifecycle is what Microsoft very strongly advocated and pushed, and now it's got a NIST publication from the government trying to include security in every step. This was Microsoft's gradual improvement from the bad old days where they didn't care about security, and they are now the leaders in security in many ways, at how a really big company with a really big product can actually incorporate security at every step. So you initiate the project, you acquire products and develop them, then you implement them, then you have operation where you figure out how to use them and apply them in real business cases, and then some kind of disposal of the stuff you're done with, and you have to consider security in all these. So you have a security plan, you determine the sensitivity of the data you're handling, you incorporate security in each of the steps here, and you have a lot of steps of controls and security testing and accreditation down here to implementation, showing that it meets certain defined standards. And then you've got secure operations with things like backup and training and so on. And then you've got the issue of when you're all done with something, how do you dispose of it in a secure manner so you sanitize the media, there isn't leftover data on it. And so you got teams here to handle these things. And another thing that comes up is software escrow. We mentioned before, if you're using a proprietary product, the company might go broke and vanish, and then you'll wish you had their source code, so sometimes they do put their source code somewhere where you can get it. So you can take over the product and take over maintaining it, which might be cheaper for you than retooling all your products that depend on it to use something else. Then you got code repositories like GitHub. This turns out to be a big problem. If you have products that used to be closed source and they turn into open source, people put their stuff on GitHub, but their coders have grown accustomed to putting secrets in the source code. And they have to change their culture to one that does no longer put secrets in the source code once you're going to publish your source code. So your APIs are services running on a cloud server typically that provides some kind of facility to take web requests. And almost everybody has got APIs now, like Facebook and Google Maps, and a great many of them are insecure. Almost every mobile device works this way. OWASP has an API toolkit to try to help you with all these security issues, so your API requests can be handled in a more secure manner. The current version of them tend to be very insecure. And then you got this issue which led to all this, which is that you don't just have one product and call it done, you have an endless series of changes and revisions and updates to your product. So you have to have change management. You have a configuration management plan and a control board to decide when you're going to change the configuration of devices and how you control it. And then there's the old DevOps. There used to be a business model like what the college has, where you have an IT team and then you have other business teams that do not know IT, and so they put requests on the IT team's inbox saying we need a server, we need a new app, and it piles up and the IT people can't keep up with it and they get very frustrated. And it turns out what's better is everybody should know IT through the whole company, and they should all be able to deploy things. That's what DevOps is. So you do not have a separate IT team. Everybody should know enough coding to automate their process, and everybody should be pushing their stuff up to the cloud. Everything should be in version control, and everything should be automated. And the idea here is, instead of having like a monthly rollout of code or a code rollout every 3 months, Amazon is the king of this. Amazon has 144,000 rollouts of new code per day. So if you have a new idea, you can write it, and if you can put it in something like, I want to have some new product thing, like a new special or something, if it doesn't break anything, it will go through these automated tests in a matter of seconds and make it all the way to the end and be visible to customers within just a few seconds. The only time that won't happen is when it fails some of these automated tests and requires human consideration, and you optimize it to make that as minimal as possible. So now you can do things like you can have an idea and you can deploy it to where 1,000 people see it and wait a half hour to see how many of them clicked on the buy button and decide if it's a good idea. You can do A/B testing. And your whole company is not just a fixed product line, it is like a living organism that adapts to the world with ideas and feedback flowing back and forth. That's where DevOps should take you. All right. That's the new thing. We're going to have a DevOps certificate here, hopefully a cloud certificate coming, but we don't have it yet. So which one is the closest to English? What they call source code? All right. Which one uses the same team for every step? Okay, that's Scrum. All right. What's GitHub? right. Code repository. All right, which one has prototypes and dummy GUIs? All right, red, all right. So,
Could have been XP.
Michael Morty. John E., that's a name I know. And the Arabic. Then you got databases. And I've got some annoying junk on my screen. There, okay, good. All right, so a database is a structured batch of data. Most companies start with Excel. They just make Excel spreadsheets, but as they grow, they have to switch to databases which can handle more complicated data structures. And with a real database, you have multiple tables storing products and addresses and credit card numbers and passwords and all these things. You use queries to find things, you insert things and delete things to put data in your database. And I see I ought to mute the remote viewers. All right, there we go. Okay, so, all right. So you got a database management system that handles all this. So a database administrator is the authorized person to change the structure of the database. You have a query language. The most common one is structured query language, SQL, but there are others. And there are now various security issues. An inference attack is where you look at the low privilege data and you find the missing items and they must be the high privilege data. And an aggregation attack is where you combine many low privilege records to deduce the high privilege data in other ways. So the most common type of database and the oldest is the relational database. This is a simple thing. It's just a bunch of tables that look like Excel tables that are connected to each other, and it describes what most people need. These other more complicated ones are used in special cases. So this is the type in the SQL injection projects we've done it. You have one table with a username and isadmin, another has a username and SSN. In this case, you'd use the username as the primary key and connect by it. You don't really use real usernames that way because people's names aren't unique enough and they aren't unchanging enough. So you assign like a user ID, like your student W number, and you use that as the primary key. But that's this is a relational database. It's just a series of square tables, and you have fields, and each field has a type. This is a text field with only a certain length. This is a number field. This is a text field with a certain format. And every type of data is defined in these nice orderly columns. So those are called rows. Columns are fields. The primary key is the one column that is guaranteed to be unique, so there can never be two entities with the same value of the primary key, and that's usually a number you make up for your company, your Amazon user ID, or your a foreign key is a field in a table that connects back to the primary key in some other table, and it might be duplicated there. For example, if you have a table of customers, there's a customer number that's unique for each customer, but you have another table of orders, and one customer might have many orders. So their foreign key might appear many times in the table, and they're connected by joins that tell the database that this field in this table matches this field in this table. And you maintain referential integrity to make sure that the primary keys are not duplicated and that they're connected correctly between the tables. So if somebody tries to change the primary key in an order table to a number that does not correspond to any known customer, they will get an error message saying you can't do that. If you are, whatever you're trying to do, you're first going to have to go create a customer with the new number and then have an order associated with that customer. But we can't have an order with no customer associated with it because there's no address to ship it to and no credit card to bill it. That's referential integrity. Relational database management systems enforce this by default. In most cases, you can turn it off, but you usually want it on because this prevents people from making changes that break the structure of the database and cause it to no longer give you accurate totals for things. Semantic integrity is making sure that the data put in a field matches the field, like you don't put letters in a numeric field. And entity integrity makes sure that each tuple has a non-null and unique primary key. So here's a database that lacks integrity. Social security number is your primary key, but here we have two records with different information and the same social security number. So in this case, this is a table that does not have integrity. It doesn't have referential integrity because the primary key is not unique. So if you ask me what is the vacation time of one customer, I cannot give you an answer. There's inconsistent data here. Normalization is, I used to teach this to companies for a long time ago. You can move tables in various kinds of normal forms. To normalize databases, you make sure that there is no double storage of anything. There is one place for every fact, and it's only stored in one place. That way, if you don't have your tables normalized, what can happen is someone can call in and say, I moved, and you change their address, but you don't change the other copy of their address. So this is why you get 2 and 3 copies of the same catalog in the mail, because people lose track by not having the tables properly normalized. There should be only one place for every fact, and it should be connected properly so it can be found. And now when you update it, it's updated, and all the future things that come from it will go to wherever they should. You have a contained user interface, which is what cash registers are, that shows people only as much information as they need to use the database. This is what's happening every time you buy a hamburger. They're looking at a screen that is showing them information about you and your transaction and nobody else. So you can have the metadata, which defines the structure of the database. That's the schema. The schema lists all the tables and their relationships and all the fields and attributes. So you have an employee table that's got an SSN in this format and a name and a title in that format, and then you've got an HR table with this information, and the SSN is the primary key here and the foreign key here, so it links the two together. And now I can print out a report of an employee with the data from both tables, and I can do totals and to find out how much total money I paid them and so on. This is what you have to control a modern company. So there are data definition languages and data manipulation languages. The most common query language is structured query language, and there are many different versions produced by different companies. MySQL is the open source one, and Microsoft uses ANSI SQL. Oracle has their own, and so on. So you can create a table, you can select a record, you can delete a record or a table, insert a record, or you can update to change the data. Here's the classic one that we talk about a lot in SQL injection. If you want to find out something from the employee, you can select star from that table where the title is detective. This will give you all the detectives in the database and everything about them. Now, there are other kinds of databases, like the database of DNS that has all the domain name systems on the internet is hierarchical. You have a root that has only information about the top-level domains, and the top-level domain like .com has information about the primary top-level domains like google.com, and then the Google's DNS server will have the details like www.google and support.google. So the data is not all in any one place, but it's all findable by a series of queries. That's a hierarchical database. Then you got object-oriented databases, where you get data and function connected in an object-oriented framework and its own kind of management system to handle these more abstract quantities. And again, you got database integrity. If you have a company with a lot of people answering the phones, like I used to work at, people are calling, and 2 people might try to change the same record at the same time. They might try changing someone's address, and someone else tries to change the same address at the same time. So now you have a problem. And what happens is you can put something in the screen, but it's not committed until you hit commit. And when it's committed, it will try to save it, and if it can't save it, it will then roll back and restore from a save point. And these are what you have to do, and you have to have a database journal for all this, just like your hard disk journal that's in NTFS, because things can fail at any point here. The power might go out, the server might crash at some point, so you end up with uncommitted records and records that were committed that needed to be rolled back. So you keep a journal for all this. If you don't, you have a mess like Microsoft Outlook Express. Microsoft Outlook Express had a database called DBX file, and it didn't have these features, and the famous thing about Outlook Express is the database is always corrupt. And there are repair tools you download from Microsoft. Your email just vanishes, stuff goes in the wrong folder. You have to keep cleaning it up because if there's any errors at any point in the system, you end up with inconsistent states. So there's different kinds of databases to handle these availability conditions. Highly available databases have multiple copies of it in multiple servers, and you have replication that mirrors a database, and there are shadow databases like Microsoft Shadow Copies that back up something while you're using it. You don't use the backup, but it's there in case you need it. Then there's data warehouses that just store vast amounts of data, like the NSA has the biggest one in the world in Utah, just storing incredible amounts of data from the phone and the system and the internet, which they then try to hunt through to find the terrorists. So this is data mining, where you hunt through some gigantic pile of data trying to find good stuff. And a lot of people do it to find prospects to send ads to, but you can search for anything in there. All right, so object-oriented design is where you write programs that are just a bunch of connected objects that send messages to each other. This is what the modern languages like C++ and Java do. Your object contains data and methods, and this is called data hiding. You don't need to know everything about the details. You handle the object as a whole, like an employee and a transaction and a product is there, and that's called encapsulation. You move the whole data structure with one command to another place. So you've got objects. The objects have methods, which are the active code that does something. There are messages sent from one object to another to tell it something should happen here. An object you can create another object based on the previous one, so it inherits methods and attributes from the parent above it. And these others I'll show you on the slide. So, for example, addy is an object that does adding. So it can take an input message of 1 plus 2 and create an output message of 3. So that has a method of addition. Then you can have delegation. So addy might get a message of 7 minus 4. It doesn't know how to do 7 minus 4, but it knows to delegate that to subby that can do it. So that's delegation. Here's polymorphism, where you feed in data of a strange type, and addy has 2 functions, one to handle numbers and another to handle text, and it can do them both. Then you got polyinstantiation. This is where you have the same data, but you have same record with the same primary key, but you give a different answer depending on your clearance. So if a person comes in with secret clearance, they get the secret information, but when they come up with top secret clearance and the same request, they get the top secret information. So you have multiple levels of data for the same primary key. There's middleware that connect your database engines to the other servers on your network, and these are called object request brokers. Things like Corba, and the Microsoft products COM and DCOM do this. COM and DCOM, this is Microsoft's distributed component object model, which has a place of great featuring in my malware analysis and exploit development classes, because this is why Microsoft made so much money, and it's also why they had so many security problems. The point of this is to make it easy to reuse code. So you can start by writing a program that does something all in one place, and you write a subroutine in that function that does one simple thing. And then you can take the same code and make it available on the local, as a service to all the processes on that machine, and then you can connect it to a network socket and make it available to everyone on the LAN or on the internet, and that's what happens from this model. So it makes it easy for you to reuse your code and sell it in a larger context, and that means you can just buy commercial code and use it, but it also means that a lot of code that was written to be in one limited secure environment is suddenly reused in a vast insecure environment, and this is why Microsoft's remote procedure calls have so many security problems, because a bunch of them are using code that was written by someone long ago in a very much more secure context. And this is what's wrong with the internet. We started with protocols like Telnet that were written when you had a terminal and a computer sitting on the desk and there was no internet. You didn't bother encrypting anything. Then you port it to TCP/IP, and suddenly you're spraying the same thing over the internet that's wildly inappropriate to use in that context. Anyway, that's Corba, Common Object Request Broker Architecture. That's the open source one. Microsoft's proprietary one is DCOM. Objects communicate with interface definition languages, defining what services they offer others, and what type of data has to come into a request service from them. So you got object-oriented analysis that analyzes the objects, their inheritances, and then you have a solution with object-oriented design. So here's what you might have an object-oriented design for an intrusion detection system. You've got a network, you have some tap of some type to collect the packets, that's your sniffer object. It now has PCAP data like Wireshark might collect. Now you send it to some analysis object that tries to decide if these are various kinds of attacks, and it sends alerts down to some kind of alerting object which now does something, like put it in the syslog, send it to the SIM, page the network administrator to tell them an attack's in progress, and so on. That's the high-level design of it in terms of objects. All right, we got some hoops. Which process removes redundant data? Okay, that's normalization. All right. And what database uses joins to connect tables? All right, that's a relational database, the most common old-fashioned type. All right, What concept is also called data hiding? It's encapsulation. All right, which one is open source and vendor neutral? All right, that's Corba. Okay, let me record this. I got Ron. Normally I'd take a break, but I know you've got presentations coming up, and also it is a CISSP skill to sit through endless boring meetings. So I think I'll just keep going to finish this up, and then we'll take a break when people are up here putting up their slides. So you have to determine the effectiveness of your security. As you know, there's bugs in everything and vulnerabilities. So there's hard-coded credentials is one common type where people have passwords just typed in the source code that can't be changed. And buffer overflows where you put too much data in containers that are too small. SQL injection where you let people put punctuation marks in fields and they can inject code. Path traversal where they can travel to directories they shouldn't be going into. And the remote file inclusion where you can add data from another server and mix it in. So those are all common vulnerabilities. Then there's race conditions where you check for something, but then later on when you use it, it might have changed while you weren't looking. That's called a race condition, where you have a brief period of vulnerability, and if you rush in and change something, then the program has the wrong effect. Cross-site scripting, insert JavaScript into a page so it then runs on another person's machine. The browser exploitation framework is a module in Kali intended to make this easy. Cross-site request forgery is where you trick someone into making an unexpected request, like they on another site. So they put JavaScript on your page and it causes them to go to some other page and make a Facebook post or buy an Amazon book or something. And privilege escalation. You can escalate to administrator from a non-administrator account. That's vertical escalation. Or you can do horizontal escalation where you get into some other user's account. And those will be possible if the passwords are handled incorrectly or the session tokens are predictable or any of a lot of problems that make it possible to somehow move over to somebody else's account. Then there's backdoors, like what the FBI wants us to put in everything, where there is some non-obvious way to get in. And the problem is if the backdoor account leaks out, then hackers can come in that way. Once you find a vulnerability, you can then disclose it. Full disclosure is where you just publish it publicly on some place like Pastebin where everybody can see it. Responsible disclosure is a Microsoft term which some people are irritated by, but the idea here is you don't just tell the whole world, you tell the vendor and give them a chance to patch it. So there's a maturity model for your software capability from Carnegie Mellon, which is their technique to make quality software. You start the early thing, which is the way all my stuff is, individual, ad hoc, and chaotic, just one guy doing it and that's it, and nobody reviewing it, nobody organizing it. The next thing is where you have some kind of project management, where someone actually organizes what's going on, so you could, for example, that guy could quit and your company could keep going, you could move on to the next person. Then there's defined, where you have a standardized process, managed, where you actually control the quality and review it, and finally, optimizing is the most mature model, where you specify the requirements, you implement them, you measure how well you achieve the requirements, and you improve your specifications for the next version, and you have an endless series of versions improving. So you can send your software to testing boards that will then check user acceptance, means the users are happy. Operational means it actually does what it's supposed to do. Contract means it obeys your contract. And compliance means it meets some kind of guidelines, like HIPAA compliance. So you might have off-the-shelf software. This is, of course, the supply chain issue, which is huge for everyone. Even if your developers are closely monitored and well-trained, they're using stuff that you got from somewhere else, hardware and software, and other people in the supply chain might be unreliable. So you got to check your vendors, consider that they might foul up, and you might have service-level agreements specifying what exactly you want out of those people. And as I mentioned, AI is rapidly disrupting this whole thing. Expert systems are systems that learn how to do a job without a human telling them how. You do not write an algorithm. They learn how to do something like play chess by just playing chess and developing their own strategies. So they have a knowledge base with some information that they've learned, and they have an inference engine that can follow that tree. And you have neural networks that simulate real brains. So you have data coming in on the inputs, and then you have hidden processing nodes, and these calculations are adjustable. And it learns gradually to adjust the parameters of the in-between nodes to achieve success more often. Bayesian filtering is where you just tell it what to do with rules from the outside, like looking for spam words to block spam. It turns out to be very ineffective and easy to bypass. Genetic algorithms are where you have a population of random programs, then you run them, and then you kill off the ones that fail and let the ones that are there combine, like sexual reproduction, to make another generation, and then kill off the ones that fail to try to reproduce evolution. That's one form of artificial intelligence. All right, and there are a lot of others. There's a free open source Stanford AI class that's very effective. I've met some people that used it to defeat the Google CAPTCHA, so that's one way to go. All right, which one does PHP suffer from? Okay, file inclusion is very common with PHP. Which one is a race condition? Time of check, time of use. All right, which one is caused by developers leaving test code in the production version? Okay, that's a backdoor. And what's the software quality framework from Carnegie Mellon? Okay, the CMM, maturity model, I think. All right, so I got Ron. I know who that is. I know who Tony is. And second day, I don't know who that is. So a couple people need to tell me who they are. And we ought to take a 10-minute break till 10 after. And people, how many people want to give a talk? 1, 2, 3, 4. All right, well, I'll just boot up the other machine. You can bring up a USB stick and put your slides on it. We got 10 minutes to do that. And people should tell me who you are. NSC and second day. I need to find out who you are. So let me get my computer out of here and put this back on the built-in computer for you folks to use. All right, folks, you're going to stop talking so we can hear him. And put on your microphone. You're good. Okay, go ahead.
Okay, my presentation is what is Bitcoin. I never bought a Bitcoin in my life, so I just sort of like researched the whole thing and figured out what it is. It's a digital cryptocurrency. There's many flavors, but I think Bitcoin is probably the most popular. It only exists electronically. You have to buy a Bitcoin from a Bitcoin dealer to convert dollars to Bitcoin. There's only a fixed amount of Bitcoins, so that gives it a supply and demand that makes Bitcoin, I think, go up and go down in value. So in January 2018, one Bitcoin was worth $13,860. Now it's around $879. You have to report any gains you made to the IRS. But the IRS will not know how much money you made on it unless you tell them. So you probably get away with not saying anything. It's not government regulated, not an official government currency. If you get cheated, law enforcement will not investigate a fraud. If you trade in it, criminals are in it to avoid the law enforcement rule of must register it because you're doing over $10,000. And Bitcoin is decentralized. It has no government rules. The Federal Reserve will not recognize Bitcoin. Will not make more Bitcoins. Will not figure out how many to produce. Will not track how Bitcoins are out there and who has how many Bitcoins. It is not an official currency of any kind. Cryptography. Cryptocurrency leans hard on cryptography. Exchange of currency is done on a peer-to-peer network to share the digital currency. Bitcoin fraud is not a source of data that can be duplicated. Bitcoins are placed on a ledger called a blockchain. A blockchain will record every transaction that has ever happened. In 2016, the complete ledger is 107 gigabytes of data. So when you send Bitcoins, the ledger will be recorded when the Bitcoin is sent. One person account gets one ledger. Blockchain, there are a lot of people that keep track of Bitcoin that are made sure that transactions are accurate. A ledger is created first. a Bitcoin is automatically placed on a blockchain. As deposit and withdrawals are made in it, they are monitored by the blockchain. If withdraw too much, you're not allowed to do this transaction. How the blockchain is kept in sync is most accurate and timely functioning. In the Bitcoin, a public key is created, and you are telling the world your account number, of the person you are sending Bitcoins to, how many coins are being sent, and this is the record of the blockchain that is accurate and up to date. Security of Bitcoins. No central bank to keep track of coins to shut down fraud. Bitcoins are kept safe based on cryptography. Keys are made that hold chunks of data that are mathematically that message that this is really you doing the transaction. When an account is created on the Bitcoin network, a wallet is created and two unique keys are created, one public key and one private key. The private key holds your electronic signature and verifies your account data. When sending Bitcoin, it goes to a public key to make sure a signature checks out. Update a blockchain. If the public key works as proof that the message signed by the private key is something I want sent to, this is unlikely to forge a digital signature. Both Bitcoin network and wallet automatically checks last transaction to make sure you have enough Bitcoins to send. It is possible that network delays means you won't always receive
Only got half a minute.
the transaction in the same order. Bitcoin has a cryptographic hash function. It will take an endpoint of any size and turn it into an output of fixed size from a transaction order is figured out. Bitcoin uses 256 computers that are specifically designed to solve SHA-256 hash problems. It takes about 10 minutes to solve one solution.
Well, you're out of time.
We're out.
Got it. Okay. Well, a lot of that stuff is changing, but anyway. All right. Who's next?
Okay, one of the most famous framework or standards in the security world is ISO 27000. Actually, ISO 27000 is a kind of series of standard. 27001 is the one that is very, very important. There are some other as well. So this time, effort, support of senior management. You also need attention to details and proper documentation. This is very, very important in the ISO 27001. So step 0, decision. Senior managers should be behind the decision. So you cannot do it in the IT department by yourself. So defining scope. So it can be done in the entire company or organization, but you can minimize the scope, saying that, we're doing it just in the finance department or blah, blah. So if you see it, if you see a company that's saying that, hey, we are ISO 27001 certified, so you have to see, their documentation, not only the certification, to see the scope as well. So documentation is very, very important. So ISO is a very small standard, just 10 to 20 pages, I don't remember exactly. And it's not free, you have to pay about $50, $60 to purchase that one, but it's a very, very tiny document. And it needs these 14 documents. And it doesn't say that how you should prepare those things. So there is no kind of standard for example, risk assessment. There is no standard to put your controls. Yes, there are some other standards like ISO 27002 that has lots of controls in that, but you're free to adopt any control from any other framework like NIST, like PCI, like whatever you want. So there is no restriction. But you see, this is one document. It can be one page. It can be 1,000 pages. Sometimes it is thousands page. Some of those results of IS risk assessment, for example, it can be 50 to 100 pages. So, but it is acceptable to to have a one-page thing if your scope is very, very limited. Realization, so gap analysis, comparison of the actual performance with the desired performance. And then prior to audit, we have to do a pre-assessment internally. And another key to have successful realization is communicate with all employees about the process in place. Internal audit is very important. Certification audit. So you hire a company to come into your company and you choose that company. It depends. Some companies, are easier to get the certificate to those things. So based on these problems, I think ISO 27001 is not a very, very good thing to make sure that that company is very secure. So it depends. For example, during those documentation, you can justify that, for our computer, we do not need password. Maybe it's okay, you have other controls in place, or your data is not very, very important. So having ISO 27001 or certified for that, it doesn't mean a lot unless you go through all the documentation. Maintaining the certification is very, very important. Most of the time, those certifications are issued for 3 years, and then you have to show that you do some continuous improvement and change management.
1 minute.
Documented. Yeah. That's the last step.
Oh, okay.
I'm done.
Okay. Well, good. Thank you.
You're welcome.
That's just begging to be messed with.
My name's Nelson, and I'm here to talk to you about 2FA. Does anyone here know what 2FA is?
Two-factor authentication.
Absolutely. Does anyone here use two-factor authentication here? By raise of hands.
I've used it.
That's like that's half. I think that's pretty good. Surprisingly, is most people don't. Less than 10% of all active Google accounts use 2FA. I'm here to talk to you about what exactly is 2FA and kind of like why you should be using it, because it's very important to not just for you to use password, but to have other methods of authenticating. So so like if you were to use your own password, there's easy ways of people stealing the password, guessing your password, or replaying the password. It's better to have other methods such as kind of hard tokens, hardware tokens, or even fingerprint scanning. So, so what two-factor means is essentially we pick two of these three things, which is knowledge factor, which is what you know, commonly your password, possession factor, which you have. For me, it's like a phone or have one of these, a YubiKey, so hardware token. And inherence factor is what you are. Commonly, it's kind of like your fingerprint, your face ID, or even your voice. So, knowledge factor. So, pretty commonly, please don't use 123455 as a password, even though it's the most common password choices. Use a password manager if you kind of generate random passwords. You want to use a password manager. That's a comic from this thing called CNIT. It's a really good way to like create safe, easy to remember password rather than trying some random combinations that you probably forget or you probably lose. So, possession factor. You can use a hardware or software token. So this is like an example of hardware token, YubiKey. A software token is kind of like the Google Authenticator. So, and also, it's also really good to store your backup codes in a safe place in case you forget it, or if you want to travel abroad and you want to bring your phone or your token, it's a great way to actually gain access to your store. So, inherence factor. So commonly, it's like fingerprint, face, or voice. Showing a demo of this. This is my phone. There's a fingerprint scanner in the back. I can unlock it with the fingerprint. I can also this. And it unlocks when you swipe up. So that's another way of actually unlocking the phone. Sidebar, what I like to do is actually install like an app blocker to this. So if I want to like look at my emails, it also asks me for another layer of authentication, which is really useful because you never know when someone steals your phone. They want to access your personal stuff. It's a great way to prevent them from doing that. So I recommend everyone to actually download an app blocker for your phone. It's really useful. And here's it's really simple to actually set up two-factor. Google, there's a whole this like web page you can do. They actually allow a lot of different ways of you can have like an SMS saying it, or even like a voice message. So if you want to do that. Amazon's pretty simple. If you have AWS accounts, please log in with 2FA because it's a good way to not like run up a huge bill. And so Twitter, yeah, it's pretty simple. It's just enable 2FA and create backup codes. It's video, but anyone have any questions about 2FA? Do they have like struggle with it, or if there's time, I can actually see if I can configure 2FA on this thing. So, any questions?
You got a minute?
I got a minute? Okay. See if I can do this really
So
quick.
I've seen different card standards like FIDO and
Yeah.
there's another 3-letter acronym.
No, Google has their own.
Yeah.
So this is FIDO compliant. I think FIDO is
Okay.
YubiKey and Google.
Yeah.
They like powered up to like have this universal 2FA kind of authentication.
Yeah.
That's kind of what they did. But yeah, so this is actually we need one. There's an NFC chip here, so you can actually use your phone to unlock it too. Do you have time to?
Is that the Neo?
Oh, that's the Neo. Yeah. All right. So unique. Come on, section.
Ubico, right? Yeah.
Go.
Sounds Japanese.
They're actually like a Swedish or
Oh, okay.
Finnish company. Okay, find the YubiKey set up my YubiKey. See what here. Okay, I have the Neo. Okay, location. I think it might be difficult. I have to log into my account to do this, but yeah.
Yeah, I think that each one of them you have to log in.
I gotta log into it. But yeah, it's actually really simple. Once you get it all set up, it's really key. You can just tap it and then it does all the cool magic, and then you're safer. It's safer than someone you just throw your password on a post-it. So yeah, I recommend everyone get this. This is really cheap. It's like 10, 20 bucks. So
Okay.
yeah.
Yeah, it's less hassle than having the code sent to your cell phone because if you don't have cell service, you're SOL.
So I work at Box, and recently we've had a lot of buzz about CJIS, and what that stands for is essentially criminal justice information.
Fox, you say?
Box.
Box, okay.
So I work at Box. It's a cloud content management company, and
Yeah.
we store a lot of different types of data. I primarily work in the federal government area. So our customers have been asking a lot about CJIS. Essentially, this is criminal justice information, and it refers to any FBI data. So that can be used for law enforcement and then also civil agencies to perform some of their missions. That can be anything from biometric data, history data, biographical data, property, incident history data. So there's a security policy which maps out quite a number of controls. But the intent of this is really to safeguard the data throughout its life cycle and its process, whether you're transferring that information, making sure you have proper encryption in place, whether it's at rest, if you're modifying any of that information, sharing that, storing any of that. So right now there isn't a certification that exists for CJIS. It's not like PCI DSS where you have a certification at the end, or FedRAMP where you get approval by a third-party agency. There isn't exactly a regulator associated with this. So one of the challenges that we have at Box is, well, how do we prove that we are compliant with CJIS and that we're protecting some of that information? So what does exist with CJIS are several different policy areas. There's 13 of them to be specific. That includes information exchange agreements. So that would be your ISAs, interconnection security agreements is what it stands for. It's an agreement between two different parties on how you're going to transfer your information. Another area is security awareness training, making sure that all of your employees have that on an annual basis. Incident response, making sure that there's a process to respond to incidents when they occur. Auditing and accountability. So having tools like Splunk or a SIEM. Access control, making sure that there's the appropriate level of access, essentially utilizing least privilege. Identification, authentication, configuration management, etc. So these are some of the key policy areas that CJIS looks for. The other thing that we did as an agency is we are FedRAMP compliant, so we do meet all of the NIST 853 controls. And CJIS leverages a lot of the controls associated with NIST 853. So what we did was we did a control mapping between the two to minimize the work that we have, and then also utilize that to demonstrate to our customers that we meet this. Some of the different things that we also help customers provide is making sure that not only is the information encrypted, but it's encrypted using a FIPS 140-2 validated encryption method. So that can be TLS 1.2 as an example of that. The other area that we do is restricting access. So one of our products is KeySafe. So that means that as Box, although we store your data, we have no access to your encryption keys. And we provide that to a third party like Amazon. So that trust isn't dependent on Box. And then another key component is data storage. So making sure that the content is stored in the US and it's not routed through a POP that's outside of the US. Yeah, that's the end of my presentation. Are there any questions?
Yeah, why does it have to be in the U.S.? Does this apply to all your data or just?
No, I think a lot of federal government data, they prefer to have that in the US. So CJIS is.
So federal government people can use Box.
Yes.
Because this is FedRAMP compliant.
Oh, okay.
Yeah.
I'm surprised they even let feds use a cloud service like that.
Oh no, AWS, Box.
AWS
Dropbox.
is very common within
Yeah, these
the
are
federal
FedRAMP
government.
compliant, so.
Yeah.
Oh, okay.
Box is FedRAMP moderate, and we actually are shooting to get compliant with high in the next year. So.
Great.
Oh, I.
That would
what-
be for the paid version, I suppose.
Oh yes.
Okay.
So I think one of our barriers right now is the FIPS 142 validated encryption. So to go off of the multi-factor authentication presentation, right now we're using YubiKeys, but that hasn't been fully validated yet, and it's in process of doing so. Anyone else have any questions?
Yeah. All right. I'm going to clean up and go to the lab.
Pass it over.